Hello guys, how's it going? Mike coming back at you here with another video on discrete mathematics. In the previous video, we talked about logical equivalence of two statements or two forms. How do we know when two forms are logically equivalent? We said that two statements or two forms are logically equivalent when for each possible combination of truth values of the components, the two forms have the exact same truth values. That is to say, their columns in the truth table are identical to each other. We also talked about some basic properties of the logical operators that we've worked with so far. In this video, we're going to do some samples and we're going to see how do we test for the equivalence or the inequivalence of two logical forms or two logical statements. So the first example we are going to work with here, we're going to show that two logical forms are not logically equivalent. We're going to show that not P or Q is not equivalent to not P or not Q. So what we're expecting to see is that in these two columns here, each column is headed by one of the two forms at the top here. What we expect to find is that for at least one of these four rows, the truth values in these columns will not be the same. So in one it'll be true, and the other one it will be false. But we have all the other columns that we have to fill in before that, so we can find these desired truth values a lot easier. So we can kick it off. We have our list of all possible truth value combinations for P and Q. P is TTFF, and then Q goes TFTF. We can then easily find the truth values for not P as well as not Q. You're just changing up the truth value of what it was. So we have FFTT down the third column, and then FTFT going down the fourth. Nothing crazy going on there. We now have our fifth column, the disjunction P or Q. As long as one of the two is true, then the disjunction is true. So first row P and Q are both true. So that's a true. Second row P is true, Q is false. That gives us a true. Third row, P is false, Q is true. That gives us a true. And then last row, P and Q are both false. So that gives me a false. And that is our third column. Next column, not P or Q. We are just taking the truth values that we found in the previous column, and we're just reversing them. So it's going to go false, 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 true. That gets me right there. And now, separately, we're going to do the disjunction of these two columns, not P as well as not Q. So a false or a false gives me a false. A false or a true gives me a true. A true or a false gives me a false. And then a true or a true gives me a true. And that is our last column there for not P or not Q. Now, take a look at these two columns. These are the two forms that we wanted to compare and see if they, or actually we want to show that they were not logically equivalent. And we see that for these two columns, there are two rows here where the truth values are not the same. One is false, the other one is true. If these two rows had the same truth values, then you would see that the two columns here are identical and thus those statements or those forms would be logically equivalent, but they're not the same. Not the same. Therefore, these two forms here, not P or Q, and not P or not Q, they are not logically equivalent. We're going to move on to one of our distributive laws that we saw in the previous video. And we said that these two things are going to be equal. So here we're just going to verify that this is indeed the case. We have three letters going on, P, Q, and R. So we have 8 rows inside of our table here. We have some conjunctions and some disjunctions showing up here. So we need to work with these guys separately before we figure out the truth values of our two forms, the one on the left-hand side and the one on the right. We have the disjunction P or Q showing up. I think at this point, pretty straightforward to figure out what the values will be going down the fourth column here. True or a true gives me a true. True or a true gives me a true. True or a false gives me a true. True or a false gives me a true. And then we can see pretty easily that the rest of this will go T, T, F, F. So that's our fourth column. We now have P or R. So now we're looking at these two columns here. So use the disjunction on these two columns to figure out what the values will be. And if you pause the video here for just a few seconds, it should be pretty easy to figure out what that is going to be. You'll find that our fifth column contains the following values: T, 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 TF, TF. We also had a Q and R, the conjunction of Q and R showing up in one of the logical forms that we wanted to find. So let's figure out the truth values for Q and R. True and a true gives me a true. True and a false gives me a false. False and a true gives me a false. False and a false gives me a false. And you actually repeat that same sequence of values. True, false, false, false. So now we have all of the columns that we need and all of the truth values in those columns that we need to come up with the truth values for our two logical forms that we wanted to compare. So now we need P or Q and R. So we're taking the disjunction of our first column as well as the column that we just found. So I have a true or a true, which is going to give me a true. I then have a true or a false. That's going to give me a true. I then have a true or a false. It gives me a true. I have a true. I have a false. That's going to give me a true. Next row, I have a false and a true. So that's going to give me a true. Then for the remaining 3 rows, I have a false or a false. So the last 3 rows are all going to be falses. So we know the truth values for one of our logical forms. We just have those filled in nicely there. Now we come up with the truth values for our final column. And we're expecting these things to be logically equivalent. So we want to see true, 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 false, false, false. But we're not going to just assume that. We're going to actually verify that by finding the conjunction of P or Q, that column, as well as P or R. So, a true and a true gives me a true. And we have that happening as well for rows 2, 3, 4, and 5. And then going down to row 6, we have a true and a false, conjunction of a true and or false, and a false gives me a false. We have a false and a true, which gives me a false. And then we have a false and a false, which gives me a false. So we see, looking at our last two columns here, that if you go row by row, you see the same truth values, both true, both true, both true, both true, both true, both false, both false, both false. So for every combination of truth values for the inputs here, the P, the Q, and the R, we're coming up with the same truth values for each of our two logical forms. So this is what verifies that the two statements or the two forms are indeed logically equivalent. And you do have to show all this work. You do have to show the values being filled in on these tables. Last one here, this is one of our absorption laws. But pause the video here, take a couple minutes or so, try to fill in the table on your own. Fill in the remaining two columns, the one for P and Q, and then the one for P or P and Q. And we are expecting that we're going to come up with the same sets of values for our first column as well as our fourth column, because the two logical forms that we want to compare are P and then P or P and Q. So pause the video here. Once you think you have it figured out, start the video back up and let's see if you come up with the correct entries for the table. Okay, so let's see what you got when you filled in your table. Hopefully you should have come up with this right here. Going down our P and Q column, the conjunction of true and true is true, and then true and false gives me a false. False and a true gives me a false, and false and a false gives me a false. So that's our third column there. And now we're going to take the disjunction of the first column and the third column, and that will give me the entries in my fourth column. So a true or a true gives me a true or a false gives me a true, a false or a false gives me a false, then a false or a false gives me a false. And we see that this is the same set of truth values as we had for just P. So this shows that our absorption law is indeed true. and that P or P and Q is indeed logically equivalent to just P. So these were a few samples here, constructing logic tables, also known as truth tables, and using them to determine whether two logical forms or two logical statements are logically equivalent. As I said in the previous video, you are going to have to know how to do this. It's going to show up on your homework. It's going to show up on potential quizzes. It also makes a very good candidate as a test question. So definitely something you want to know how to do. If you have any questions or comments, be sure to drop them in the comment section below. Otherwise, until the next video, take it easy, guys.